All right, let's go over this review. So we've got number 1, what is the recursive formula for the sequence that is given by the explicit formula a sub n equals negative 4n plus 1? So if you look at this explicit formula that is given, it looks linear, like y equals mx plus b. So this is arithmetic, because arithmetic sequences are another way of expressing a linear model, a linear equation. So since we're writing the recursive formula for an arithmetic sequence, we're going to need 2 things. We're going to need the a1, whatever that is, and a sub n equals a sub n minus 1 plus whatever the d is, the common difference. Okay, so I need those 2 things. I need to fill in these 2 things. So when you look at the explicit formula, because it's in slope-intercept form, the slope is the same thing as the d. So the m is equal to the d, the slope-intercept form, right? So I already know that the d is a negative 4. But I need a1. So to find a1, you just have to plug in a 1, replace the n with a 1. So it's negative 4 times 1 plus 1. Negative 4 times 1 is negative 4. Negative 4 plus 1 is a negative 3. And there is my first term. So here is the recursive formula. So that answers number 1. Number 2, the first row in a theater has 30 seats, and every other row has 3 more seats than the row in front of it. How many seats are in the first 10 rows of the theater? So that means you have to find all the seats in the first row, add it to all the seats in the second row, third row, fourth row, fifth row, all the way to the 10th row. You're adding things up. So you know that there are 10 rows. There's 30 seats in the first row. And there's second row, third row, fourth, fifth, sixth, seventh, 8th, 9th, 10th. Let's find them all. Every other row has 3 more. That means we're adding 3 each row. So if we add 3 each row, 30 plus 3 is 33. Add 3 more, you get 36, then 39, 42, 45, 48, 51, 54. Am I doing this right? 3, 6, 9, 11, 12, 15, 18, 19, 20, 21, 23, 24, 27. So 57, okay. Just adding 3 more. And then you just add them up. So it just depends on the calculator that you're using. I'm going to use my nice graphing calculator, which you guys don't have one like this, but I mean, it works like any other calculator. 39 plus 42 plus 45 plus 48, 51, 54, 57 equals 435. We can all add stuff up, right? So 435 seats. We could also use a sum formula instead. These will also be given to you on the board. So, or you could do it this way. This is a sum of an arithmetic sequence, so you would use S sub n equals n over 2 times a1 plus an. So you could use this formula instead, okay? So if I were to use this formula, or I'm going to use it right now, I'm adding up the first 10 rows. So I'm finding the sum of the first 10 terms pretty much, so S sub 10. Which means I got to replace the n with a 10, so 10 over 2, times the a1, the first term is a 30, plus an, this represents the last term. Well, the last term is that 10th term there, and it's a 57. Okay, well, 10 divided by 2 is 5, and 30 plus 57 is 87, so it's basically 5 times 87, which is 435. It better be the same thing. So you have 2 ways that you could go about it. You could just find all the terms and add them up, or you can use a formula. The formula does get you there faster, but you do need to know what your first and your last terms are. So you still need to do all this. You just don't have to add them up if you want to use a formula. It will be quicker. Okay, or you can use formula to check your work and make sure that you got the right answer, or vice versa. All right, number 3 says write an explicit formula for the nth term of the sequence. So before we write an explicit formula, I need to know which type it is. Is it arithmetic or geometric? I see the numbers are decreasing, and we're going into decimals. So it looks like they're decreasing by division, which means we're multiplying by a fraction. So you know 8 divided by 4 is 2. So that means we must be multiplying by a 1/4 or 0.25. You don't have to convert it to decimal, but decimals are nicer to work with in the calculator. So I'm going to keep it in decimal form. But either way is fine. Okay. So this is geometric because we're multiplying by a number. And if you're ever not sure, check it in your calculator. 8 times 0.25, it should equal 2. And it does. Times 0.25, and it should equal 0.5. And it does. Times 0.25, it should equal 0.25. Or, well, there should be a 0.125 in there. So there's a typo in there, but that's okay. But it does. Okay, so this is a geometric sequence. And the explicit formula for that is a sub n equals a1 times r to the n minus 1 power. So this is the formula we have to use. Okay, so we just have to plug in all the things. You have to plug in the a1 and you have to plug in the r into the formula to write it for this particular situation. So a sub n equals, well, the a1, the first term is an 8, times the common ratio. We could write it as a fraction or as a decimal. It really doesn't matter, to the n minus 1 power. I think the one on the test is written in as a fraction form, so I'm going to keep it as a fraction. But like I said, it doesn't matter. It means the same thing. All right, so we answered this one. We answered this one. On to number 4. Says a rectangular box with a square base has a length and width equal to W. The sum of the length, width, and height of the box is 20 inches. Write a function that represents the volume of the box in terms of width. So let's draw a picture. Here's my square end, and I'm making a box, a rectangular box. So even though it has a square end, it's rectangular in shape for its volume. Okay. So it says that the length and the width, so length and width are equal to W on the square end. So they're talking about all 4 sides of the square, okay? But it says the sum means plus, of the length, width, and height, how high the box is, or it's on its side, so its height is laying down, but that's still a height. And the height of the box is 20 inches. So sum of length, width, and height. So that means these 3 dimensions add up to 20 inches, because sum means 20. Well, then we can combine like terms. So 2W plus H equals 20. And let's keep it there for right now. We'll come back to that one. Okay, so then it says write a function that represents the volume of the box in terms of the width. Well, volume of a rectangular prism of a box, just like our last partner quiz, is volume equals length times width times height. Well, length and width are using the same letter, so it's going to go W times height. Well, W times W is W squared times the height. Now here's the thing. It says these words that represents the volume of the box in terms of the width. So that means we only want W in our formula. So that H gotta go. So I'm gonna make it disappear, but I have to make it disappear mathematically. So I am using a capital H, but my lowercase and capital H, they mean the same thing. So what I need to do is I need to go back to this one and I need to isolate this H. So I'm gonna take away the 2W from both sides so that I can move it so that H is isolated. And now I have negative 2W plus 20. And now let me switch this back to capital. Now I have something to replace this h with. So I'm going to do that next. So I'm going to have w squared times, I have to put parentheses around it because it's a quantity, negative 2w plus 20. And then we distribute it. So we got to distribute that w squared. So I'm going to get w squared times negative 2w is a negative 2w cubed. W squared times 20 is a positive 20w squared. And there's our volume, our expression for the volume. And that was number 4. Number 5, let me fix my papers here. Number 5, it says the design of a spherical Christmas ornament has a volume of V of R equals 4/3 pi r cubed times 6 minus 2r, as shown in the graph below, where the radius must be less than 6 centimeters. So here's our graph, the volume of a spherical ornament. Now I just want to mention that this graph right here does not help me very much when it comes to figuring out what the question is asking. It is asking what the max volume of the ornament is. So there's no hill, there's no top of the hill, there's no bottom of the hill. So I don't know what a max or even a min is on this graph, because it just looks like not a complete curve. So the graph doesn't help me. So what's going to help me is this. So let's rewrite that function down. So V of R equals 4/3 pi r cubed times 6 minus 2r. Because just like this test is square partner quiz, the last one that we took, we have factored form. We can find the domain, which will give us the zeros, and if we know what x values we're using, then we can figure out which one is the maximum, which one's the biggest one. So that means I have to set this equal to 0 to find the zeros, my domain. Okay, so what I'm going to do is I'm going to break apart these factors and set them each equal to 0. And we're going to solve each one. So pi is just a number. Let me see if I can find it on this calculator. There it is right here, second pi. So pi is just a number. If I were to hit enter, pi is just a decimal. It's just a number. So this 4/3 pi goes together. It's just a coefficient. So to get it separated from the r cubed, next to means multiplication. So to undo multiplication, you're going to divide by 4/3 pi on both sides. So we're getting rid of this. So r cubed equals. But 0 divided by anything is just 0. And then we need to undo that cube on the r, so we have to take a cubed root. But the cubed root of r cubed is r, but the cubed root of 0 is just 0. But we kind of expected that, because when we're finding the domain of a volume of a box or of an ornament or whatever it is, volume can't go below 0, can't be negative, so that's the lowest number it should go to. Now I need to solve this one, so I'm going to go ahead and add the 2r to both sides. 6 is equal to 2r, and then I want to solve for r, so I need to get rid of the 2 by dividing by 2. 6 divided by 2 is 3, so r equals 3. Okay, so my domain is from, x is from the smallest, or 0 less than r less than 3. So this is my domain from 0 to 3. Remember, we can't equal 0 because it makes the volume 0. And I can't equal 3 because it makes the volume 0. But everything in the middle, in between, is totally okay. Well, what numbers are between 0 and 3? Well, they are r equals 1 and r equals 2. There's only 2 numbers in the middle between 0 and 3, and they're just 1 and 2. So we're going to try these. We're going to test them out. What we're looking for is the max volume. So whichever one is the biggest is the answer. So to test them out, we have to plug them back into the original. So V of 1, plugging in a 1 for the r, is 4/3 pi times 1 to the third power times 6 minus 2 times 1. Well, 2 times 1 is 2. 6 minus 2 is a 4. So in parentheses, that's really a 4. 1 to the third is just 1. Now these numbers, 4/3, pi, 1, and 4, they're all next to each other, so we have to multiply them. 3 is a denominator number, but 4, pi, 1, and 4 are numerator numbers. Ignore the pi for right now. 4 times 1 is 4. 4 times 4 is 16. So this is a 16 pi all over 3. So there's our first volume. Now for the second one, we're going to plug in a 2 and see if it's bigger or smaller. Because remember, whichever one is the biggest is the max volume, is the answer. So 4/3 pi times 2 cubed now times 6 minus 2 times 2. Well, 2 to the third power is 2 times 2 times 2, which is 8. 2 times 2 is 4. 6 minus 4 is a 2. So now this time I have 4 times 8 times 2. Well, 4 times 8 is 32. 32 times 2 is 64. So this is 64 pi over 3. Oh, 64 is bigger than 16. This one is the maximum one. So that's the answer. Now the one on your test is a lot easier. It's multiple choice, and the graph on the one on the test is a lot more useful than this one is. FYI. The reviews are always harder on purpose so that you can be challenged enough so that you're prepared fully for the test. Okay, so it says sketch the graph of a cubic function with a positive leading coefficient and a y-intercept at -5. Can you do another one that looks different? So, cubic function, that means you have something cubed and it's a positive leading coefficient. So we know if it's cubed, the degree is odd. And if it's got a positive leading coefficient, it's an odd positive. So we know that those are down on the left and up on the right. Now, it does say it has to have a y-intercept of -5. So that means it has to go through the y-axis at -5. So plot a point there. And it's odd degrees, so we know it's got to go down on the left, up on the right. Just because it's a third degree doesn't mean it has to go through the x-axis 3 times. It just has to go a maximum number of times at 3. So let's just let this side go down from that y-intercept and then go up on the other side. This would be a cubic function. It just means that it only has one real 0 and the other 2, because there's 3 total, must be imaginary because it only crosses through once on the x-axis. Let's see if we can make another one. So we want it to look different, but it's still got to go through 5. 1, 2, 3, 4, 5 on the y-axis, okay? And it still has to be a cubic. So let's make it touch the x-axis more than once. So we know that it's going to have to go up here. But if I want to touch the x-axis again, let's have it touch right here and then come back down. And that's a cubic. It's hitting the x-axis twice, so it has 2 zeros, which means that the remaining zeros are imaginaries, but that could happen too. Okay, so there's my odd function. My other one. Describe the end behavior of the graph of -5x cubed in nerd language. So again, you're looking at end behavior. You look at the degree first. It's a 3. 3 is an odd number. Then you look at the leading coefficient. It's a -5, so it's an odd negative. So that means it's going to do the reverse as number 6 did. It's going to go up on the left and down on the right. Okay, it's going to look kind of like that. And so remember, with end behavior, it's always going to start off with this. As x approaches -infinity, f of x goes somewhere. And as x approaches +infinity, f of x goes somewhere. Remember, f of x and y are the same thing. One's function notation, one's regular notation. So you just got to remember that when x is going to -infinity, you're looking at the left side of the graph. When x is going to +infinity, you're looking at the right side of the graph. For f of x, you're looking at if it's going up or down on that side. So on the left, at -infinity, the arrow should be going up. So that would be a positive infinity. On the right of the graph, the y value is going down. So it should be a negative infinity. And there is our end behavior. In nerd language, speak nerdy. Number 8. Okay, so it says, classify each polynomial function in the table as even, odd, or neither. Select exactly one answer in each row. So remember, it's got to be all or nothing. So power of 2, power of 1, power of 0. Any constant has a power of 0. 0 is even, 1 is odd, 2 is even. We've got a mixture. This is a neither. It's got to be all or nothing. All right, next one. X to the 5th, x to the 1st. 5 and 1 are both odd degrees, so that's odd. 2x squared and a 7. Well, 7's a constant, so it automatically has a hidden x to the 0. 0 is even, 2 is even, so this one's even. X to the 3rd and 5. Well, 5 has a hidden x to the 0, but 3 is odd, 0 is even. We've got a mixture, so that's a neither. Okay, so it went neither, odd, even, neither. You will have one just like this on your test. Number 9. So it says Javier divided the polynomial x cubed minus x squared minus 5x plus 1 by the polynomial x plus 3, but his solution is wrong. It's incorrect. So we need to find his mistake. So we know when we start these, we have our first goal. It's an x cubed. Let's see if he did it right. And then he distributes. X squared times x is x cubed. X squared times 3 is a 3x squared. So far, so good. But then you have to subtract. So that means this will become negative and this will become negative. These two cancel. Negative x squared minus 3x squared is negative 4x squared. So far, so good. His first line is good. Now this is the new goal, to get a negative 4x squared. So then you got to test out the next term. Negative 4x times x is negative 4x squared. Negative 4x times 3 is negative 12x. And then you're subtracting, so you have to switch the signs. Double negative changes these both to a positive. These will cancel because negative and positive 4x squared, they're opposites. Negative 5x plus 12x is 7x. And that's not what he put. This should be a positive 7x. So he added those wrong. So line 4 is where the mistake is. So if you look at your answer options, that means it can't be A, it can't be B. Line 4 is not negative 7x, it's a positive 7x, so D is it. Number 10, factor fully. So let's see. First of all, I see a GCF, so let's factor that out. I see a greatest common factor of a 3x. When you factor that out, you're going to be left with x squared minus 4x plus 3. And now you have an easy trinomial in parentheses right here. You can product sum it. The product is a 3. The sum is a negative 4. Two numbers that multiply to 3 and add up to negative 4, well, it's got to be 3 and 1. And they both have to be negative because negative times negative is positive. And negative 3 minus 1 adds up to negative 4. So when you pop them in, it'll be an x and a negative 3, x and a negative 1. Don't forget the 3x we factored out at the beginning. And there it is, fully factored. Number 11 is a different kind of factoring one. This one is a difference of cubes. And we have a formula for that. It is, when you have a cubic minus a cubic, it is a single a minus b times an a squared plus an a times b plus a b squared. The minus plus plus. So this is our formula for a difference of cubes. Okay, so now let's use it, but we need to find the a and the b. So obviously, x to the third is x to the third. So a is x. But what to the third power is 64? Now, if you're ever not sure, you can use your calculator. And let's see, on this one, I have to find it a different way. But there's ways to take like a cubed root of something. So a cubed root of 64 is 4. So 4 times 4 times 4 is 64 then. So 4 to the third is 64, so that's my b. All right, so I have my a and my b. So it's gonna go a minus b, so x minus 4, times a squared, which is x squared, plus a times b, x times 4 is a 4x, plus b squared, well 4 squared is 16. And there's our answer. And then number 12, it says, write a polynomial of 4th degree with zeros 0, -1, and 2 with a double root at 2. So we got a double at 2. So that means we have another 2 on our list. Okay? So x equals 0, x equals -1, x equals 2, and x equals 2. All right. And here we go. So we have to unsolve each of these. So the first thing is, well, x is just a factor of x. X equals -1, you gotta move the -1 back over, so you have to add it, so x plus 1. You have to move the 2 back over to unsolve x equals 2, and it would be x minus 2, and then you have another one. And then you gotta multiply these out. You can only multiply out 2 at a time. So I'm gonna do these 2 first. It doesn't matter which 2 you decide to do first though. Just distribute that x. So that would be x squared plus x. And then bring everything down. Remember, you can only do 2 at a time. So I'm just gonna do the next 2. So x squared times x is an x cubed. X squared times -2 is a -2x squared. X times x is a positive x squared. X times -2 is a -2x. Okay, and then I gotta combine like terms on those x squareds. -2x squared plus 1x squared is a -1x squared. So I'll rewrite it over here. So now I have x cubed minus x squared minus 2x. Put parentheses back around it, and don't forget we have this last factor of x minus 2 that we need to multiply in. Okay, so x cubed times x is an x to the 4th, and it did say it was going to be 4th degree. X cubed times -2 is a -2x cubed. X squared, -x squared times x is a -x cubed. -x squared times -2 is a positive 2x squared. -2x times x is a -2x squared. And -2x times -2 is a positive 4x. I ran out of room there. But if you notice, I stacked those x squareds. They're opposites. They're going to cancel out. And all I have left, oh, I need to combine these. I have x to the 4th, and then -2x cubed minus 1x cubed is a -3x cubed, and then plus 4x. How about that? That's number 12. All right, number 13. Samantha identified the graph below as the polynomial function f of x equals x plus 2 times x minus 2 times x plus 1. Explain why Samantha is incorrect. So she's wrong. What did she do wrong? Well, let's see. She's saying that this function describes this graph. So let's check it. If we were to break these apart and set them each equal to 0, we would get x equals -2, x equals positive 2, and x equals -1. Well, this graph, though, it does have a 0 at -2. It does have a 0 at -1. It does have a 0 at positive 2. But if you notice, this is just an x times an x times an x. So this is a 3rd degree, meaning an x to the 3rd power. Well, that means that it would be down on the left and up on the right. but that's not what it shows. It shows both going down on the left and the right. So the graph shows an even degree, but her equation shows an odd degree. So why is Samantha incorrect? Samantha's equation describes an odd degree while the graph shows an even degree. Okay. Because we had to say why she was incorrect, so we had to explain. All right, number 14, list the possible rational roots of f of x equals 5x cubed minus 2x squared plus 3x minus 3. We're listing the possible rational roots, so we need the PZs. Well, you got to remember that the PZs are a fraction. We need factors of the constant over factors of the leading coefficient. This is the definition of possible zeros. So first of all, we need to find the constant. Well, which number represents the constant? Well, this number right here, the constant on the end, that is the constant, the number on the end. So there's my constant. And we got to ask ourselves, what are factors of 3? Well, factors of 3 are positive and negative 1 and positive and negative 3. So there's my numerator. Now I need my leading coefficient. My leading coefficient is the number in front of the highest degree term. And that LC, that leading coefficient, is a positive 5. There's my LC. Well, factors of 5 are plus or minus 1 and plus or minus 5. So now I got to divide these all out. Well, 1 divided by 1 is 1. 1 divided by 5 is plus or minus 1/5. 3 divided by 1 is 3. And 3 divided by 5 is plus or minus 3/5. So here are my possible zeros. Positive and negative 1, positive and negative 1/5, positive and negative 3, positive and negative 3/5. That's 2, 4, 6, 8 possibilities to try out. We know that there's only going to be 3, but here are 8 of my possible ones. Okay. Number 15, when the polynomial f of x is divided by x minus 1, the remainder is 4. Sorry, I'm going to box this real quick. When f of x is divided by x plus 2, the remainder is 0. Which of the following describes the graph of the polynomial? So I want to use my highlighter. It says when the polynomial f of x is divided by x minus 1, the remainder is 4. What does that mean? Well, when you solve this, when x equals 1, y equals 4. That means the coordinate 1, 4. Okay. And then it says when f of x is divided by x plus 2, the remainder is 0. Okay. So that means that if I were to solve that, x equals negative 2, y equals 0, because it divided in evenly, because you find zeros when they divide evenly. That means you have the coordinate negative 2, 0, which is an x-intercept. It's a 0. X-intercept, 0, root, solution, they all mean the same thing. All right, so now that I know what I've got, now I can select my answer options. We know we have an x-intercept at negative 2, so x-intercept at negative 2, x-intercept at negative 2. So that means it can't be C, and it can't be D. Sorry for that in the background. My husband's doing it right now, and it's like the worst time ever. So it's one of these two. And we know it's got to pass through this point, positive 1, positive 4, and that is letter A. And there it is. Number 17 says, which of the following represents a quadratic function that has zeros at x equals negative 3 and at x equals positive 1? Well, these are zeros. So that means that when x is -3, y is 0, because we're on the x-axis. And when x equals, oops, it's supposed to be a 1, y is 0. So we're looking for -3 and 0 to match up and +1 and 0 to match up. Well, this one shows -3 and 3 matching up. Nope, that's not what I want. I want -3 and 0. It does have the 1 and 0, but I want both of these zeros at the same time. So A is not it. Letter B, it has -3 and 0 matching up, and it has 1 and 0 matching up. This one's probably going to be it. Let's check the others. If I were to solve each of these factors, I would get x equals -3, and I would get x equals -1. I want the -3, but I don't want the -1, so it's all or nothing. I don't have both. And then this one, I get x equals +3 and x equals +1 when you solve them. +3 I don't want, I want a -3. +1 I do want, but I need both. So B really, truly was the correct answer. Number 18, almost done. Since the graph of a polynomial function p of x is shown, which of the following must be a factor of p of x? Select all that apply. Well, the number of factors is the same as the number of zeros. We have 1, 2, 3 zeros, so that means that I should be selecting 3 factors. So that first 0 is x equals -1. This one right here is at x equals +2. And this one right here, 1, 2, 3, 4, is x equals +4. So when you unsolve each of these, you're going to get that this one, in factored form, was a factor of x plus 1. This one, in factored form, is a factor. You got to move the 2 over, so you got to subtract it, x minus 2. This one, you got to move the 4 over, so you have to subtract it. You get a factor of x minus 4. So x plus 1, x minus 2, and x minus 4. So just those 3. Boom, boom, and boom. And then last but not least, number 19, it says the graph shows the function f of x equals x cubed minus 2x squared minus x plus 2 in the xy plane. What is the solution to the inequality when x is greater than 0? Well, not when x is, when this function is greater than 0. So when the y is greater than 0, graph the solution on the number line. So if the y is greater than 0, that means you want positives only. So the positive y is on the top, so it's above the x-axis. So we want strictly above the x-axis. So at this point, this is where you should grab a highlighter, and you should highlight the parts of the graph that are strictly above the x-axis. This part is above, and this part is above. All right, so I've got 2 pieces here. So you have to look at the x values. So this piece, this little upside down parabola, is between -1 and +1. So that means these x's are between -1 and +1. Over here, that x value of 2, well, to the right of 2 is where that part of the graph is above the x-axis. So those are x's that are greater than 2. So because we can't equal the 0, I don't have the or equal to part. These are all open points on the number line. So -1, +1, and +2, all open points. These x's are between -1 and +1, so you signify that by connecting them in the middle. These x's are greater than 2, so numbers greater than 2 are to the right. So you need an arrow to the right, to the right. And there it is. And that's it, you guys. Have a good one.